Alright, we're into week 2 and starting off with lesson 1.06, Measuring Angles, part 1. Our objectives in this lesson are to define and identify an angle, the parts of an angle, and angle pairs, and to measure and classify angles. Hopefully a lot of this is review for you. Here are some new terms that you're going to be seeing in this lesson: acute angle, angle, exterior of an angle, interior of an angle, obtuse angle, right angle, straight angle, and the vertex of an angle. And as you can tell, it's all about the angles. Alright, let's look and see what we've got going here. How to name an angle. This particular angle right here can be named in 3 ways. You can name it angle B, and that is because B is the vertex. You can name it angle ABC, starting out with this point, A, B, C, or you can go in reverse order, angle C, B, A. What's important is to notice that when we use a single letter, we use the vertex. When we use the 3 letters, the vertex is always in the middle. Those are very important rules here. As far as the sides are concerned, if you've got ray BA is a side and ray BC is a side. When we're talking about them in angles, we refer to them as sides, not rays, but they are rays. Okay, and notice here that an angle is formed by 2 non-collinear rays. That means non-collinear, remember 2 points consist of a line. That means they're collinear. Any other points on that line are also collinear. Well, if you look, A and C aren't on the same ray, which makes them non-collinear. And let me see, I think I've already talked about all these points right here. Oh, you'll see some like this where you're using a small letter or number between the sides of an angle and near the vertex. You'll see some examples of this as we go on in our lesson. So let's name this angle. Now, if we were in a live session, I would be having you poll this. But let's look. The actual angle is right here. The blue lines are the blue rays. Correction. Here's ray DA and ray DG. D is the vertex. So we know we could name this ray D. Not in the list. So we know ray E's out. That one's not working. If we look here, since D is the vertex, what I'm going to do is I'm going to look and see, I know D's out. It's choice D. Okay, so I'm left with B and C, so let's look where EDA gets us. Oh, I think I called that G maybe earlier. I don't know. EDA. And that one's going to work. I think I did call it G. That's my fault. I'm sorry about that. This is ray DE. So C is going to be the correct choice. Now, how do you measure an angle? I tell you what, this is the most confusing part of geometry, is looking at a protractor. Okay? To measure an angle, you use a protractor. Angle PQR is a 65-degree angle, and we say that the degree measure of PQR is 65, or simply the measure. This is what you'll see a lot. Measure of angle PQR is equals 65. Okay, look at what they did here. If the angle's pointing to the left, you're going to use the numbers on the outside of the protractor. Okay? If this angle was pointing to the right, you would use these numbers on the inside of the protractor. It's always confusing which numbers to use. So remember, if it's pointing to the right, you're on the inside. If it's pointed to the left, you're on the outside. Let me see if there's important information. Dun dun. They're telling you how to do it. There's always a line going across the bottom of a protractor, and you're going to align that with one of the sides of your angle. See how they've got it all lined up right here? And then wherever this side is pointing and wherever it's crossing, sometimes you may have to extend your angle to see where it's going to cross. You can't see these numbers very well on this protractor, but it is crossing 65 on the outside. I'm looking through here, place the center point using a protractor. Let me see if I can get this up. Whoa, look at what I did. Oh, I know what I'll do. Put this over here. Sometimes these little shows that I've got going on here don't work so well, but I'm trying it out. I might have a video for you to watch on using a protractor. We'll see how it works. Okay, let's look here at classifying angles. A lot of you are real familiar with a right angle. It's going to be measuring 90 degrees, and look how perfect it is. You're going to have two rays that are perpendicular. Okay? Just close it. We're not going to have that video. It's not going to work for me. So, an acute angle, it's cute. It's so little, it's cute. That's the way I always think of it. That means that its measure is going to be less than 90 degrees. Then you have an obtuse angle. Its measure is greater than 180, less than 90. Let me see. Okay. I didn't read the statement right. 180 is less than the measure of angle C is greater than 90. Okay. So if you have an obtuse angle, it's going to be greater than 90, but less than 180. Alright, and all I did was I just set it backwards. Okay, so obtuse angle, I always just think of it as a big angle. It's really big. Okay, obtuse is going to be greater than 90, less than 180. So let's look at these examples. We've got points OR, F, and P, and they're connected with the segments as shown. So we've got R, oh no, let's start off with O like they did. O, R, F, and P. Okay, they're connected with the segments shown below. Name the vertex of angle RFP. RFP. Well, first, I don't even have to look at the picture to tell, since F is in the middle of the name, that tells me it's its vertex. But let's look here. If I go, oh, my colors, I like colors. And let's make it a little larger so we can see it on the screen. R, F, P. There you go. So now you can get a visual of the angle and see that F is the vertex. So I'm going to erase those because I'm going to need to use that screen again. I'm going to do something fancy here. I noticed when I loaded this slide I didn't have the answers already on here, so I'm actually going to have to write them. The vertex is F. Alright, name the sides of angle RFP. Oh, I should have left those up there. RFP. Okay, remember that the sides are rays, so you need to name them like you're naming rays. This side right here is going to be ray F, R, and this side here is going to be ray F, P. So when you write those, you have to write it that way as well. So we're going to say ray F, R, and ray F, P. Alright, now it says name a point on the interior of angle ORF. Well, first I've got to draw them. Let me see, angle ORF. So R is going to be the vertex. So I'm going to have R to O, R to F. And if I'm naming a point that's on the interior, that's going to be this point right here. And when we're talking about the interior, it means it's between the sides. Okay? So let's name that point. That is going to be, and when you're naming points, all you have to do is write the letter. So easy. Name a point on the exterior of ORF. Well, if you look right here, you're looking for a point that's outside of the ray. So you're going to have S. Oops, looks like a 5. Or you could even have the letter P, point P. It's on the outside as well. Okay, let's see what we've got next. Oh, segment SJ is perpendicular to segment TS and point T is on segment SZ. Okay, now when they're telling us they're perpendicular, they're letting us know that a right angle has been formed, because here's SJ and here's TS, and they form a right angle. So we already know that's 90 degrees. Point T is on SZ, so here's segment SZ. All right. Classify each angle as acute, right, obtuse, or obtuse. So let's look at TSJ. TSJ, so that means S is the vertex, TSJ. And I've kind of already given you that answer. I'm really good about that. I don't know if that's a bad teacher thing or a good teacher thing. If we were going to classify that, we'd call it a right angle. And I'm going to use that symbol, right angle. And the reason is it equals 90 degrees. I can't make the degree symbol very well with this pad. There we go. That's a big old degree symbol. Okay, let's look at another angle. All right, dun, dun, dun. JTZ. So JTZ. Now on this one, you can tell just by looking at it that that is greater than 90 degrees but less than 180 degrees. So remember, if it's a big angle, it's going to be obtuse. So let's write here, obtuse angle. And we're going to say that we're going to write it just like they did. 180 is greater than the measure of angle T. Oh, I should have put JTZ, but y'all forgive me. And greater than 90. Okay, let's see what the next one is. And y'all have probably already answered these, but I'm going to go through it slowly and answer them with you. SJT. So I'm going to go to S to J to T. Alright, this one is obviously less than 90 degrees. Less, remember when it's little, it's really cute. So if it's less than 90 degrees, it's going to be acute. So let's write that down here. We can come down here and we can say it's an acute angle and it is less than 90 degrees. Well, you're going to get a little dot there. It's a dot or a big O 0. Okay, let's see what's next. Oh, I've already posted the links for Unit 1 in the doc sharing. So even though I don't have them listed here, if there are links to help you with 106, they're going to be in that document and doc sharing. What we've learned today, let me get my pointer going here. An angle is a figure formed by two rays that do not lie on the same line. An angle consists of only the points that lie on its sides and vertex. All other points on the angle's plane are either in the interior or exterior of the angle. And you can find the measure of an angle in degrees by using a protractor. And then what you should be doing is view the lesson in the LMS, reading the pages in 11 through 14 in the reference guide, completing these following problems in the problem set. This is good practice to make sure you're going to do good on the quiz. contact me before you take the quiz if you don't understand anything, because there are no retakes or corrections. And make note of any general questions you may have when you attend CC on Thursday. And that's the end of lesson 106.